Okay, so now we're going to come up with a formula to approximate area under a curve. So as we discussed, the idea is that we're going to use rectangles, a number of rectangles, and find the area of these rectangles to approximate the area under some kind of funny shaped curve, like this arbitrary function f of x. So to begin with, this example, I have 4 rectangles, but we're going to use this example to extrapolate to the completely general case where we have n rectangles also. So to begin with, again, the idea is to find the area of each of these rectangles, and the area of a rectangle is width times height. So we're going to assume that these are equally spaced rectangles. To find the width of 4 equally spaced rectangles, the width of this entire thing is the difference between this point and this point, or b minus a. And we divide that up, and however many rectangles there would be here. So in this case there's 4, so it would be b minus a over 4, but in general it would be b minus a over n, where n is the number of rectangles. Okay, so there's an expression for the width of all of these rectangles. Now we need to figure out the height of these rectangles, and so for this example we can construct the height at the right endpoint of each of these subintervals. So I'll have height there, here, here, and here. And if I want to come up with an expression that tells me where each of these guys is, well, the first one is at x2. And if we think about where x2 is, it's going to be one width away from the left endpoint. So we're going to evaluate this function f at 1 width, right? Or 1 b minus a over n. The next one, the height of this rectangle is going to be whatever the height at this subinterval piece would be, which is 2 rectangles over, right? 2 widths over. So we could again think about this as starting at a and adding 2 b minus a over n, because that's what those widths are. Similarly, the next one would be 3 widths over, so plus 3 b minus a over n. And finally, the last one would be 4 rectangles over, 4 widths over. And it would just continue no matter how many, and it would end at that. It would end at f of b, right? This would always be the last one. So in general, what we have here is we have a sum of evaluating the function at multiples of those widths. So if we write that in summation notation, we have, first we have the width, b minus a over n, and the height is the sum from 1 to n of f of a plus one of those widths, a plus I times b minus a over n. And here is a formula then that we can use to approximate the area under the curve using however many rectangles we would like.